Thanks everybody for coming to this talk. I will talk about a project, a research program, which is trying to help governments to reach the Sustainable Development Goals. And like many programs in the Turing, it started with an academic conversation between myself and my collaborator, Gonzalo Castañeda, from one of the leading think tanks in Mexico. And from an academic conversation, it was picked up by the United Nations Development Program, which asked us to adapt our methodology to the Sustainable Development Goals in order to advise countries. So in this process, we have gathered a few allies, especially from the Mexican government, like the presidency and a couple of local governments, the Ministry of the Treasury. And that is because they are really interested in knowing how could they prioritize their resources across the many different policy issues that are covered by the Sustainable Development Goals, something not trivial at all. And the way we do this is first by thinking about development as a process, a transformative process. So you can think of this process as a machinery that takes on inputs, perhaps capacities, human capital, resources of all sorts, and it produces development. And usually countries measure this development through development indicators, like the ones that track the SDGs. And the interesting thing is that when you look at international agendas, like the SDGs, all countries are trying to align to them, and they are measuring the SDGs through these indicators. But what about the inputs? So let's talk about one of the main inputs, which is the resources that governments put into public policies that will make these indicators move. Well, those inputs, which would be, for example, public expenditure data, actually we don't know too much about them. You will not find data sets telling you how much countries are spending in all the indicators that are tracking the SDGs, at least not in a disaggregate level that would be useful to provide policy advice. It's quite an interesting problem, because that means that if we want to understand how the input transforms into the output, we need to model this engine, this machinery. We need to model the process of development. In particular, we're going to model the policy-making process. So we have development indicator data, and we're going to try to reverse engineer the process to infer how governments are prioritizing the resources to reach development goals. So what we developed is a computational approach to model this process, and the process is actually quite complex. So if you speak to a policymaker that is involved in this, in helping their countries to reach this agenda, you will hear different stories about how difficult it is to actually reach the goals that governments plan ahead of time. So let me give you my mental model, and this is basically the spirit of our approach. Suppose you have a central authority, which could be a treasury, for instance, and the central authority is tasked with allocating resources across different policy issues. Here I'm representing these policy issues as different SDGs. So suppose the government allocates resources to quality of education, SDG number 4, with intention of improving it. Some agent in a public agency, it can be a minister or the entire agency, is going to take those resources and produce policy and transform those indicators. Okay, this sounds very good, but any policymaker will tell you that in the process of transforming resources into policy outcomes, you have inefficiencies. So you can have inefficiencies, for instance, because of lack of capacity, because you have badly designed contracts with the companies that you hire to perform some projects, or simply you can have plain corruption and diversion of public funds. That means that there is no one-to-one mapping between the resources to the outcomes. And we need to understand that process. We need to model it, to take it into account. And obviously, this is hard to observe in data. You cannot actually see it. So governments, well, they try to monitor the performance of their indicators, and they try more or less to evaluate, well, if I have a rough idea of how much money I'm putting in this generic topic, and I'm getting this progress in my indicators, I should be able to get an idea of how efficiently are the resources being used. The problem is that there is a network of interdependencies. In the literature of sustainability, these are called interlinkages. And let me give you an example. Suppose there are improvements in public health, SDG number 3, and in infrastructure, which is SDG 11. Let's say that kids in rural areas now get their vaccinations, and they also have public transport, which can take them closer to the schools in shorter time. And because of that, the kids are going to perform better in the PISA tests, which are one of a piece of information used to build indicators on quality of education. So there's going to be improvements in education, not because of the resources that the government put in the topic, but because of externalities produced by improvements in other SDGs. Now imagine this, obviously this is going to opaque any attempt to supervise the inefficiencies of the policymaking process. And now imagine that this process takes place selecting across not only 7 SDGs, but I'm talking about hundreds of different development indicators. And these hundreds of indicators, they interact with each other in complex forms. So what we propose is a method that models exactly this process. And obviously for this, we're going to be inspired in these 3 aspects: that development is a multidimensional challenge, that the policies involved, these different dimensions, interact with each other in non-trivial ways, and that this gives place to a complex policymaking process. And it's a process that generates data that we see in the real world from a micro level to a macro level. So its individual agents produce aggregate indicators that see in the real world. So our proposal to deal with this is a computational approach. We're going to simulate artificial agents that are policymakers, and we're going to put them to interact on a network of interdependencies between the indicators. This is going to allow us to simulate the data that we see in the real world about the indicators. So once we're able to match that data, we can infer some things that do not exist in the real world data, like the priorities that governments put across different policy issues. So let me give you a sketch of the logic of our model. The idea is that you have the government, which has some goals in mind, the little circle below. The government puts the resources to the policymakers. The policymakers transform those resources. The real world dynamics take place. There are interdependencies. The indicators change. But there are some incentives to be inefficient. So the policymakers are going to learn how much inefficiency can be non-supervised by the government. So there's a learning process. Here is where AI comes in. So there is a behavioral model behind this. And the process is, the government is also learning about the performance and deciding whether it is worth to keep investing in certain topics that perhaps are not being the most efficient. So the government might shift and adapt. So it is an adaptive model. And if you think about it as a computational package, what the model does is if you have a set of development indicators for any country, you take those indicators, give it to the model. You have a network of interdependencies, and I can give you references on different methods to estimate those networks. There are many ways. You give those networks to the model, and then you give the goals or the aspirations that the government has in mind. For instance, the Mexican government published last month its National Development Program, which is the program to achieve certain goals in the next 6 years. And they have very specific goals. For instance, internet coverage. Their benchmark is 2017, we have an indicator of 85% coverage. And in 6 years, we're going to be at 97%. So it's that precise. So these are the aspirations of a government. So you give that to the model, and the model is going to simulate indicators as they reach those goals, and it's going to tell you, these are the priorities that you would develop, that you would allocate across this process. And we can also estimate other interesting things like the inefficiencies that take place at the level of each indicator, which also you cannot observe in real-world data. Now let me give you an example of a typical output of policy priority inference. And for this, I'm going to use some data. It's not exactly about sustainable developments because this was developed before we performed adaptation to the SDGs. So we're taking socioeconomic indicators only, not environmental ones. They are roughly 80 indicators. We're going to do this for more than 100 countries. These indicators are organized in 13 pillars, just like the SDGs. The World Economic Forum has 13 development pillars. And we're going to do 2 types of analysis. One is the retrospective one. So you have the data, and you simulate how the country went from its initial indicators to their final values. And we're going to infer the priorities. So what we're saying there is what the government has been doing during that period. And the other type of analysis that we can do is the retrospective one. So this is a kind of counterfactual analysis. We can say, well, suppose I want to simulate a scenario in which this country would have copied, would have imitated a successful country. So I want this country to reach the indicators of Canada or the US. Then we can simulate that, and we can tell you these would be the priorities that the government would develop if it would imitate effectively that development model. And a typical output would be this, would be, for example, this bar chart just showing you the distribution of resources in a retrospective point of view. This is a hypothetical country. We have aggregated indicators across different, across the 13 pillars, and you can see very clearly, for example, that this country developed more priorities to technological readiness than to public health, etc. What is more interesting is to do an exercise in the prospective form. So suppose we take the data from Mexico and we say, well, what would be the priorities that Mexico would need to put in place if it would want to become Switzerland? So we take the Swiss indicators as the goals of Mexico and simulate Mexico getting there. These would be the priorities. The top priority is education, the second is public governance, research and development, etc. Then what if we change the goals of Mexico? What if Mexico would want to imitate Japan? You can see that there is some reordering of priorities. So this is very useful advice for countries who have certain goals in mind. What about if we look at another country, let's say Albania, trying to become Spain or trying to become China? You can see that the reordering of the priorities is more aggressive than in the case of Mexico. So what this is telling you is you have to think about three things when giving this kind of advice to countries. The first is we need to take into account who we are. So what is my network of interdependencies? Because that represents the socioeconomic structure. The second is where I am. Where am I? That is, what are my current indicators? What is my current state of development? And the last one is who I want to be. What are my goals? Am I really going to align to the SDGs? So now that I have presented you retrospective and prospective analysis, I can use those two to estimate policy coherence, which is a very popular topic in the policy community, in the international policy community, and yet we don't have methods to quantify it. So we're going to do that. And just to give you an idea how important it is, this is one of the first paragraphs of the Policy Coherence for Sustainable Development report from the OECD. You can see that the Secretary General mentioned some of the ideas that I have talked to you through this presentation, like not working in policy silence, interconnectedness between the different SDGs, synergies, trade-offs, which are positive and negative links, policy effects, etc. So what we do basically with this analysis, we're trying to assess whether governments are being coherent with what they want to do, with the goals that they want to achieve. This means we have somehow to understand what are their actions. And for this, we're going to use the infer policy priorities. And we're going to use the particular case of Mexico. This is a very good example because Mexico joined the OECD in the 1990s. And the argument was that Mexico wanted to become like the members that were already part of the OECD. So this is a prospective analysis. Mexico wanted to imitate those countries. And here for us, what policy coherence is a very intuitive concept. So you can estimate what Mexico has been effectively doing since it joined the OECD. That would be your retrospective analysis. Then you're going to estimate what Mexico would do if it would have imitated one of the OECD members, for example, Canada. Then you're going to compare the two priorities from those two analyses. If those two things are similar, that means that their actions have been similar to what Mexico would have been done if it would have really wanted to imitate Canada. So coherence is similarity between those two allocations. If they are very different, then Mexico has been incoherent. And this is to give you an example. This is the result that we get for Mexico, trying to imitate Japan. On the horizontal axis, we have plotted the allocation of resources from the retrospective analysis, what Mexico has been doing. In the vertical axis, you have what Mexico would have done if it would have become Japan. If the two allocations would be identical, if Mexico would be coherent, all these dots would be in the diagonal line. Now, this is a very nice plot because you can see something here that is, if your dots are above the diagonal line, that means that you are overspending in topics where you should spend less. And if you are under the line, that means you are underspending. These are called allocative inefficiencies, a very important concept also in the community. Well, so because we can measure actually the distance from each dot to the diagonal line, we can build an index. And the index works like a correlation coefficient, goes from -1 to 1. If it is negative, you are incoherent. If it's positive, you have coherence. So we're going to do this exercise for Mexico, trying to imitate each country of the OECD. And we're going to ask ourselves, has Mexico been coherent overall? So here's the answer. On the horizontal axis, we have plotted the countries of the OECD according to their income per capita. And in the vertical axis, you have the coherence index for Mexico trying to imitate each one of these countries. The result is that Mexico has not been coherent. Not at all. Now, as a Mexican, this was not surprising, to be honest. But maybe I was expecting at least to have a positive correlation, because that would mean that at least Mexico has been doing the effort to be coherent with the most advanced nations, which is not the case. So very disappointing. And perhaps if you are not familiar with the Mexican context, this is not telling you much. But what if I tell you that we can also capture successful cases? So think about Korea. Korea joined also in the 1990s, the OECD. The argument would be very similar to the Mexican case. And we know that Korea has been successful, and also that Korea has tried to imitate Japan for many years. So in a similar plot, we would expect Japan to have a particularly high index. And this is what we have. Japan is at the top. Korea has been most coherent with Japan. And also there's a positive correlation. What about another case, Estonia? Estonia joined recently. It's a recent member of the OECD. Perhaps we wouldn't expect such a strong coherence as Korea, but we would expect that Estonia would be more coherent with the Nordic model, with the Nordic countries. It is well known that it has tried to follow their steps. Here you have it. Denmark, Finland, Sweden, and also Japan are the countries with which Estonia has been most coherent. And think that this is coming from an AI model on how the policy-making process works. This is telling you, this is validating our approach. It's telling you that our theory, the theory that we're using to explain the dynamics of development indicators, is capturing something that has been qualitatively, extensively shown in the field. So with this, I want to close, and I want to thank you for listening. I invite you to check out these websites where you will not only find the academic papers that the project has produced, but you will find also dissemination materials produced by the UNDP. So this is actually an AI tool that is endorsed by the official voice of the Sustainable Development Goals. And thank you very much.
Thanks very much. Thanks very much, Omar. We'll have some questions after the next speaker, so write down your questions and we'll come back to it. Our next speaker is Neave Cleary. Neave is currently based in the mathematics department at the University of Oxford. She's also, and we're very proud of that, one of our Turing fellows. And Neave works on economic development and urban systems. I'm just going to invite Neave now to join me to give a presentation.
Okay, so today I'm going to be talking a little bit about cities. It's one of my core research interests. And cities are particularly exciting to study for a variety of reasons. Internationally, we see extremely large levels of rural to urban migration. And these bring various planning challenges. So how to organize a city, how to adapt a city, and how to cope with things such as informal settlements in more developing contexts. So there has been an interesting and growing multidisciplinary effort, very much a collaborative effort to try to understand how some of the challenges that are presented in the urban context can be resolved. And alongside this multidisciplinary effort, there's been the emergence of big data. This is not a sort of a new phenomenon to any of you, but particularly in the urban context, the presence of a great number of different sensor technologies and different types of mobility technologies has enabled us to understand the dynamics of people in cities and various other quantities in very close to real time. So cities present a really interesting policy opportunity, not least because policymakers are particularly interested in these interdisciplinary efforts, the research inputs that come from the diverse set of fields, including data science. Okay, so as part of the scientific push to understand cities over the last couple of years, there's been an effort to try to see if there are some universal laws that are at the foundation of sort of the dynamics of cities. So I think the phrase that would sum up the sort of foundational thinking behind much of this work is that a city is very much more than the sum of its parts. There's something special about cities, and cities are able to generate more, particularly from an economic perspective, they're able to generate more output than would necessarily be expected, particularly with respect to city size. So on the left-hand side here, we just have a very simple plot of population in cities against the number of patents that the cities produce, and we see across the world a conserved, what we're going to call a superlinear relationship. So the number of patents scales more than proportionally with city size. So larger cities produce on average many more patents than you might expect. So this superlinear behavior is actually present across a large number of economic indicators, suggesting that there's something about cities that is very powerful in driving interactions that are sort of at the foundation of economic productivity. And so we just see on the right-hand side here a couple of those other economic indicators that we observe that scale superlinearly with size. So in this particular talk, we're interested in one of the sort of foundational questions of urban economics, and that is, why do firms and industries choose to cluster in cities? Why do different cities specialize in different types of economic activities? And the sort of, what are the driving factors behind the decisions of firms to cluster with other industries and other types of firms? Okay, so this question has been around for quite a long time. And in sort of the late 1800s, Alfred Marshall suggested that there were three main channels or factors at play. The first one being labor pooling, the idea that firms like to, industries tend to locate with other industries that share similar skills. And so this is just a graphic that shows you in Manchester. It's a cluster of textiles firms together with online textile and clothing retailers. This is an example of a cluster of firms, or cluster of slightly different industries that have chosen to locate in close proximity in order to benefit from a shared skill pool. Many of you will be familiar with the US expertise in producing cars. So this is just the kind of automotive alley, so to speak. This is a plot of assembly plants and locating in close proximity to their suppliers for the production of cars. So this is just an example of the second externality, the idea that firms tend to locate close to their customers and their suppliers, particularly industries that have sort of higher transport costs. And so the third externality is slightly trickier to quantify, but it is this idea that firms choose to co-locate in order to benefit from knowledge spillovers, that they want their employees to interact, and that is the kind of the idea flow between industries that generates these externalities. So here's a sort of plot of some of the big tech firms in San Francisco who've clearly decided to locate in close proximity to both probably benefit from a very relevantly skilled labor pool, but also to benefit from this idea of there being sort of ideas in the air, in the mist. Okay, so one of the key research questions that has been around for a while is which of these externalities is the most powerful in general, on aggregate across a wide range of industries. And so because each of these externalities gives rise to a very similar prediction, the idea that industries will cluster in space, it's been quite difficult to disentangle from an empirical or a data-driven point of view which of these externalities is the most important factor. And so relatively recently, there was a paper by Ellison Glaser Kerr who took a sort of what I'm going to call a sort of industry pairing approach. So they tried to look at the relationship between the co-agglomeration or the co-location of industries with each of these different channels. And we're going to discuss in a second how each of these different linkages were derived from data. Okay, so the key idea here is that we want to look at patterns of co-location of industries. So basically the linkages between industry pairs, and this linkage or this edge weight here corresponds to the propensity of these pairs to co-locate in space. And then we have a similar metric which quantifies, so in the first case, in the case of labor sharing, we can quantify the propensity of firms to want to share labor in terms of their employment, in terms of their occupation demographics. We have very good data measuring customer-supplier linkages between industries. And then finally, we can use patent data to estimate the importance of this sort of knowledge sharing between industries. And so the key idea of these papers is that we want to try to estimate which of these channels is the most important driver of firm co-location or industry co-location patterns. Okay, so I'm not going to go into too much detail, but the key takeaway fact here is that we can use this type of linkage data in order to estimate the strength of the relationship between co-location patterns or agglomeration patterns and each of these externalities. And along with some co-authors, we estimated the strength of these relationships over time. And so what we observe is something that you might expect, is that over time, co-location patterns are increasingly driven by labor linkages, right? So firms increasingly care more and more about getting access to the relevant skills that they need, and value chain linkages, transport costs, as you might expect, have decreased in importance over time. So this supports our sort of key idea that when firms choose where to locate, which city to choose, they're most interested in the type of skilled labor, the type of sort of embedded know-how there is in the local workforce. And so that prompts us to investigate more the dynamics of labor relations between industries in general. Okay, so I'm going to talk a little bit about a project that I did with the Irish government, where this is exactly the kind of question that we were interested in. So, as many of you might be aware, Ireland, of course, is kind of well known as a Celtic Tiger economy, but at the same time, it's quite fragile. It's been prone to quite a few different sort of boom and bust cycles. It's a very high-tech and services-oriented economy, but as many of you will probably be aware, we have a very high proportion of foreign multinational firms. So as a percentage of GDP, it's quite staggering. And so some previous analysis that I have done with some collaborators suggests that there's actually a worrying distance in terms of skills between foreign multinational firms and domestic firms. So effectively, the types of activities that foreign firms are engaged in are not really connected in terms of the types of skills and knowledge that they use as domestic firms. And this is very worrying from a policy perspective, because one would hope that some of the knowledge embedded in the foreign multinational firms would actually diffuse to the local economy and perhaps be instrumental in sort of raising the sort of sophistication level of some of our domestic firms. Okay, so we can study some of this knowledge dynamics between industries by looking at the patterns of worker flows between industries. So effectively, the data set, our sort of key data set here, is a data set that maps transitions of workers between industries. And this is going to enable us to probe, in a sense, the structure of knowledge mobility within the Irish economy. Okay, so the linkages that we previously discussed, right? So these linkages between industries, and here we're measuring the strength of the linkage in terms of worker flows. We can represent these linkages as a network. So here the nodes are industries, and the edges are the number of workers that switched between industry pairs. So this is effectively a model of labor mobility between industries in Ireland. And so what's interesting here, so here the nodes are sized by employment. So we see on the left-hand side, we see that most of the employment is focused in these quite clustered regions of the network that are really focused on services. So finance and the public sector, and we have retail and hospitality there in the bottom. Here the nodes are colored by sector, and we see that the sector classification doesn't really capture very well the structure of the network. In fact, we have a lot of grouping of industries. So if industries are located in close proximity here, it means that they tend to exchange a lot of workers. They exchange knowledge, and they're very connected in terms of skills. And so we see, this is just another visualization that basically shows the degree of worker mobility between sector pairs. And we see that there's extensive mobility off the diagonal, which means between different sectors. And so we need to employ a different type of, we need to employ some data science analysis techniques in order to quantify the clusters that we observe in this network. Okay, so the approach that we're going to take is that of community detection. And the idea here is that we're just going to apply this algorithm in order to detect groups of nodes. So that is groups of industries that are highly connected within the industry network. And the idea here is just to let a random walker, so we just have a walker, and that walker is allowed to roam on the network and jump from node to node. And this walker will become trapped in regions of the network where there's high density and high levels of connectivity. So this is just the general idea behind this type of community detection algorithm. And the longer that we let the walker roam on the network, the larger the communities that the algorithm is going to find. So we have a sort of parameter that we can control, which is the time that we allow the walker to roam on the network. And longer times are going to correspond to larger communities. Okay, so this is just a visualization of the network for one specific time. So this is just giving us a sense that actually this algorithm, so the nodes are now colored corresponding to the communities, the node grouping that we find. And we're assured by looking at this diagram that in fact this algorithm is capturing better than the official sector classification, the groupings of nodes, so the industry clusters in the data set. And so as I mentioned, we have a time parameter, so that's on the x-axis. And as we let the random walker roam for longer on the network, if we look at the blue dots, we see that the number of communities decreases. So we have fewer but larger communities. And we have another metric here, which I'm not going to go into too much detail about, but the variation information effectively is a measure that captures how robust the community partition is at that particular time. Okay, so here we have a visualization of the communities for different characteristic times. So the first thing to notice is that as the time gets larger, we have larger communities. And one of the very interesting features is that we see this natural division of the network for large times into two, which basically chops the manufacturing and retail sectors off from the high-tech services. So this, in a sense, as we've discovered in our data, this divide between services and manufacturing, which is something that many of you will be familiar with from the news cycle. So we can visualize this process of merging communities into larger communities in the form of a dendrogram. And this is basically starting off on the left-hand side with a set of rather small communities and showing that as the time increases and the random walker walks for longer on the network, we merge these communities. And the interesting point here is that communities that stay distinct for a long time, they resist merging, right? They're very isolated. They're very disconnected from the network. Those communities are very well formed. So, and this particular plot can tell us which types of sectors are very isolated in the Irish economy. They exchange workers within the industry cluster, but they're not connected to the rest of the economy, which has repercussions for a number of different things that we're going to see in a second. So we see here that the public sector and finance remain distinct for a very long time. They are only forced to merge with the other sectors at very late times, which means that the public sector and finance in particular are disconnected from the rest of the economy in terms of knowledge exchange and skill overlap. Similarly, the farming and food sectors at the bottom are quite late to merge with the rest of manufacturing, and construction. So we see this kind of hierarchical decomposition of our industry network, which gives us quite a lot of information on the structure of knowledge flow and worker mobility in the Irish economy. Okay, so what are the implications of this analysis? So our analysis has extracted from data groups of industries, so our communities, that are effectively, we can see them as knowledge clusters. These are groups of industries that tend to hire from each other, and some of these industries are very disconnected from the rest of the network. So I think a particularly interesting case in point is finance. So finance is, as we've seen, it's quite disconnected from the network, but it similarly has a very large employment size. However, if a new finance firm is moving to Ireland, for example, and they want to hire, the amount of labor that's available, skilled labor that's available to them in industries that are related, that exchange workers with finance, is very few. So on the y-axis here, we have the ratio of labor, of employment that's available to an industry as a proportion of its own industry employment size. So this is, in a sense, this is a little bit worrying for the finance sector in Ireland because there is a very small pool of labor from which they can hire. And so this has implications for industrial policy. And it actually turns out in the literature, and we also validated in this case, that the size of available labor, so this labor in related industries, is predictive of the potential of the industry to grow in the future. Okay, so one of the key interests of the Irish government from this project, and it's something that we haven't completed our analysis on, but I just thought I would mention it, is the impact of, so as I mentioned earlier, it's quite concerning that foreign multinationals are quite distant from domestic firms. And so what we want to do here is actually quantify the movement of people from multinational firms to domestic firms and try to understand if there are any productivity gains for those domestic firms that are recipients of these workers. And so the literature would suggest that there should be, but in the Irish case, the evidence is limited. And that's sort of where this research is going at the moment. And finally, just to mention a new project that is being funded by the Alan Turing Institute in association with the Office of National Statistics and HSBC, and it is to build this type of labour mobility network for the UK, and to use it to try to understand the resilience of UK cities in terms of their ability to redeploy or reallocate their workforce in response to various pressures. So the key idea here is that, if you are a UK city and you have many connections within this labour mobility network, then you have many options. If there's some kind of pressure, such as automation or Brexit or climate change, and over either a shorter or longer period, you need to effectively reallocate your workers from old industries to new industries. The structure of this network will actually be informative in telling us which cities are better posed or better positioned to reallocate their skills into new industries and be sort of more agile from a sort of skill perspective. Okay, thank you very much.
Okay, so I hope you've been writing down some of your questions. We're going to have a little panel session now. I will attempt to chair, so bear with me. And I'll kick off with a few questions, but I will, because we haven't done it so much in the previous sessions, we'll give you a chance to ask questions to the panelists as well. So I think you've given some great example of how data science and I wouldn't say AI perhaps in this case, but how data science is applied in a policy context from a research perspective. And maybe starting with you, Omar, in your experience, how kind of policymakers globally right now are kind of using this kind of techniques, AI, machine learning, in perhaps in developing policies or perhaps in monitoring the effectiveness of policies at the global level?
Yes, well, if we think, for instance, in the United Nations system, they have been quite open to these technologies for a while, especially when it comes to disaster management, right? All GIS, spatial modeling. Recently with the Ebola outbreak, they were using really sophisticated network methods of contagion networks. But when it comes to perhaps more economic topics, this is unexplored territory. And in particular, for instance, for the SDGs, kind of a holistic approach to advise countries, there are no methods that really do this in this fashion. And the reference that I can give you is that the UNDP has a website where they have collected all the methodologies available to advise countries on SDGs. They have done this under mandate of the General Assembly since last year. And you will find there that you have a wide range of methodologies going from anthropology to kind of system dynamics, which is a technology from the 60s, but it's not really AI. So they are just starting to tap into this technology when it comes to the SDGs.
And perhaps the next question is for you, Neave. One thing that seems to strike a strong message here is that data science has the potential to disrupt the way economics is used in the context of policymaking. Can you give us a bit of a flavor of how much of a disruption this is causing right now, or is likely to cause?
Yeah, I think that's true. I think that, I think particularly in economics, there were some very clear failures of the discipline to predict some of the recent crises. And I think that combined with the new availability of big data and the greater awareness of the potential and tools available has really opened the eyes of policymakers who are genuinely really interested in on the one side, usually the interests are relatively short term in terms of what is kind of the next policy agenda, but on the other hand are very, very interested in understanding what is the best thing to do without too much regard to a disciplinary slant. And so my personal experience is that policymakers are extremely open to engaging with people from all types of different disciplines, particularly data science. And I think that the key challenge there is that when you're applying slightly more sophisticated techniques, it takes a little bit of time to be able to explain those in a simple enough way in order to give the policymakers confidence, in a sense, that to interpret the results. But I think generally speaking, there's a huge potential and appetite there. And I think in terms of disruption, I mean, certainly there is, and I think there's some tensions on various levels. I think that data science tends to take a very high-level aggregate view on sort of thinking at a sort of what can we observe at the city level. And I think in many other disciplines there's a tendency to think at very local levels and to think that you're missing a lot of nuance if you're kind of trying to find patterns in sort of higher-level data. So I think that the next challenge in a way is to try to integrate better those two perspectives, particularly more qualitative social science alongside big data science, and to try to, rather than have those two things compete a little bit, to try to think about how we can take data from different scales and try to come up with more holistic or more rounded insights, rather than have the two kind of come from very separate communities.
Thank you very much. I think it's time to open the floor for questions. So we have a roving mic over here. If anybody wants to ask the speakers a question, don't be shy.
Hi, thank you. A question for Omar. I'm almost worryingly excited about your research, and it's a very straightforward question. What is next? What's on the roadmap? And also in terms of funding for these type of projects and your ability to scale. Thank you.
So let's say that the version 2.0 of PPI was what the academic thing that we developed. Right now we are developing the 2.0, which is turn it into an SDG tool. Like the transition was, before we were only looking at socioeconomic indicators. We tend to interact in a positive way. If a GDP grows, education probably is going to grow as well, equality. But when you introduce environmental variables, then you have negative relationships, and then it's a bit tricky. So we did that adaptation. And the next step, 3.0, is to link with the growing trend of open fiscal data. So there are countries that are starting now to publish the data that I say doesn't exist yet. couple of countries are doing it. We're working with the organization that is pushing for this agenda, and that's going to take this to a whole new level. And in terms of scaling, well, the UNDP is doing their part there, and they are basically bringing this to different countries. So we started with Mexico, but we are growing already to a couple of more countries to disseminate this methodology.
Questions over here? Yeah.
Again, a question for Omar. Thank you. You mentioned the UN use of this in the Ebola response. And I'd just like to hear a bit more about how the UN used these data and what they did with it.
So it's not exactly my field, so probably I don't have too many details. But from the last time that I went to New York and I spoke with Pedro Concensao, which is he's in charge of the Human Development Report, he said that when the outbreak happened, they called the top experts in the top labs that analyze epidemiological outbreaks. And they'll have these huge simulation frameworks in which you have data on airports, for example, air traffic, and then you simulate how, like, counterfactual scenarios and outbreaks and what measures could stop it.
Next question. As you're still thinking, I'll ask, sorry, one over here, sorry.
I guess a question on the policy implications of the cities analysis, whether it implies that cities should collaborate with each other or better off competing. Yeah.
I think that will really depend a little bit on, so our analysis aims to quantify the extent to which cities are able to redeploy their skill base based on sort of existing connections between industries in a sense. So in terms of, in some cases, it may be better for, so in some cases it may be appropriate for a city to kind of specialize but also to think about linkages, right? To think about building linkages, and there's different ways to do that. So one of the ways would be to collaborate. There are different ways of importing skills these days, whether it be via using sort of online labor markets, or thinking about specific training to build linkages between industries. So I think about it a little bit more on a skill-specific level. And so I think the key thing is that, and one of the quotes I had on the screen is that there's a huge data deficit in the UK. We really don't know who is good at what, and that's something that's really only, I mean, it seems like a very fundamental question, but we really don't know which places are well specialized in what type of industry and what is the sort of local skill base. And we do know from the sort of international literature that what you currently do now constrains what you can do in the future. And so that's what this analysis is trying to get at. It's trying to get at those linkages that both think about what is possible and think about what's your kind of exposure. In the sense, it's almost the converse, what is not possible. And if we can identify some particular pressures on industries, then we can think about quantifying the ability of a city to respond to a shock. And so it's building those linkages. There are a couple of different ways of doing it. But in many cases, it will be about collaboration and building new linkages, but there are a variety of ways to do that.
Yeah. Okay. So whilst you're still thinking of other questions, I'm just going to ask one to you, Neave. To what extent the Irish government has kind of looked at the results from your research, and if they have taken notice, which I hope they have, how they're using those results, and how, what changes are they making?
Yeah, so it's actually been quite an interesting journey. So I was a postdoctoral research fellow at the Harvard Center for International Development, which some of you may be familiar with. It's led by Ricardo Hausmann, and they've developed some very interesting online mapping tools, really at the country level, to understand diversification. And so while I was there, I was involved in running some workshops for policymakers from different countries. And at one of the workshops, there was an Irish policymaker from what was then Forfos, which is now the Department of Jobs, Enterprise and Innovation. And we just got chatting, as you do. Always, if you meet an Irish person abroad, you go and say hello. And long story short, he said, well, we would be really interested in applying this analysis to Ireland. Would you be interested in doing a short consultancy? So that was quite a number of years ago, in about 2014. And so I basically, at that stage, applied this. It's analysis of expert competencies. And it was that initial analysis that identified this big kind of skill distance between the exports of multinationals and domestic firms. And so that actually kick-started a long-standing relationship with them. And we're actually on the third phase of that now. So the second phase was analyzing this labor mobility structure. And we have some really interesting conversations. I mean, so, I presented this sort of around about this time last year in the department in Dublin. And what I really find interesting when I meet with policymakers is the insights that so you show them an image, and for me it's a network, and I don't see anything very special about a specific node, but they will really zoom in on a node and look at its connections and say, well, we know that's a specific huge multinational laundry company, and that's got all these connections, and that's really interesting. And they have a lot of anecdotal evidence in their mind that they're trying to kind of map to the data. And so I find bringing the results of your data analysis to policymakers kind of almost brings it to life, because they have so much kind of background knowledge, and they've got so many kind of working theories of what's going on in the economy that they immediately try to interrogate your data. And so we actually, very recently, we are just actually signing a new collaboration agreement where they have hired actually 2 economists inside the department, one of which is going to be seconded to the statistics office to gain access, because this type of data is very difficult to gain access to. It's data on individual workers, so it's quite tricky. And so we actually have to have somebody working in the statistics office in Dublin. And so this third part of the analysis, which is really concerned about looking for productivity spillovers between multinational and domestic firms, is actually going to be which is actually, to be honest, a little bit intimidating. It's going to be the main research input into the national job strategy. So it's kind of, it has started off at a fairly, consultancy, quite a low level, and has built up over quite a number of years to be quite a very strong collaboration. And so I'm based in a maths department, so I think on both sides this is a somewhat of an unusual, unusual partnership, but it's one that I hope continues and is fruitful.
Fantastic, thank you. Question at the front.
Hi, my question's for Omar. I suppose the quality of your model depends entirely on both the inputs and then the quality of the indicators you're using. And so how do you deal with that, especially if you're dealing with sort of countries that have lower quality of data inputs in the first place?
Yeah, well, like with every empirical tool, garbage in, garbage out. But an advantage that it has over other approaches is that you don't really need to rely on enormous amounts of data. So to give you an example, the typical advice of a consultant from the World Bank would be, give me your data, I'm going to run a regression, I'm going to explain GDP in terms of other indicators. And many times, the amount of data that a single country has is not enough to have to consider 10 indicators, because this data is very coarse-grained, like you collect it annually. So then they combine data from other countries together, and then they run the regression. And what's the problem there? That then the advice is not anymore about that country. It's some hypothetical country that represents all that mix of countries. Our method doesn't have that limitation. We actually don't rely on the tools that econometrics rely on. So, of course, better data, better outcomes, but it does have important advantages over other approaches.
Any more questions? Yeah, just at the front.
Hi, this is also a question for Omar. I was wondering, with the direct sort of comparability approach of this economy to that economy and what could lead to improvement using another economy as an indicator. I was just wondering if there, particularly through the UN, if there are any sort of political interpretations that came from that in the way, I don't know, countries asking advice were looking at like, oh, that particular country, and whether, I don't know, any international relations kind of contexts were considered in people's response. That's all.
So I'll divide the answer in two. So first, the comparisons. The nice thing of having these networks of interdependencies is that if you have them for each country, that basically captures the context of each country. So in that way, you can do certain comparisons. Of course, you have to take care of having the same indicators. Depends how good of a comparison you want to make. Then in terms of political stuff, we try to leave that outside. And if you see, there are 3 inputs to the model, and one of them is the goals, the aspirations. And that may come from different agreements. It can come from a societal agreement. It can come from really following an international agenda, or it can be a completely discretionary determination of some authority. So we're agnostic about that. So as long as a country has some aspirations, the model will just do its job.
Okay, any more questions? Oh, yeah.
Hi, this one's for Neave. I was just wondering, you mentioned a couple of times that it's really difficult getting data on individual workers, and that was part of the reason you couldn't carry out your research in the UK. And I was wondering, is there significantly more data available on Irish workers than on UK workers?
Yeah, so that's an interesting question. So in Ireland, there are data sets. Well, effectively what we have access to is so it's held in the Central Statistics Office. It's very much under lock and key, and you have to go through like a lot of different processes to get access. Actually, I've never personally seen the raw data. I've always had a government statistician work on it and export high-level aggregates. So in Ireland, there's basically every firm files a list of their employees, and we can actually map those firms to industry classifiers, and so we can actually look at this data set over time. And so basically, effectively what we want to do to create our underlying data set is to count the number of workers that transition from one to another. So it's fairly simple. In the UK, actually, that data is, I think, what we need is a longitudinal data set, right, where we see the same worker over time in order to capture these transitions. And actually, in the UK, that is not available to researchers. So the HMRC does have this type of data, but it isn't available really at all to researchers in the way that it is in Ireland. And so we have a 1% sample in the UK, which will enable. And so this is a longitudinal data set that has specifically been, sampled or designed in order to let researchers do kind of longitudinal analysis. So we just have a 1%. But at the same time, because the UK population is so large relative to Ireland, we still will be able to get some relatively robust patterns. But I think in the future, there is some sort of slow movement towards opening up these much larger data sets. And so certainly having worked on this 1% sample will put us in a really good position to kind of bid or lobby a little bit to try to get access to these much larger data sets at a later point in time. But personally, as of now, I've never spoken to anyone or heard of anyone who has had access to the full data set. People have had access to slightly larger randomized samples, but not ones that are trackable over time. So they might have a 10% sample, but it's changing. The 10% is changing every year, which is actually not helpful for us. So it is all about the details, but actually it varies quite a lot in different countries what different researchers have access to.
Okay, I think one last question. Final question.
Thank you. Earlier at the impact stage, Professor Diane Coyle, she briefly mentioned that despite one of the challenges public policymakers might face is that regardless of their efforts to use data science to inform policymaking, ultimately whether the policy gets actually adapted to society is down to politicians. And I was wondering if you agree with her that that's one of the challenges, and whether you might have any thoughts on how to address the challenge.
I can start, and then I guess Omar. So I guess Omar and I have had experience in policymaking on slightly different levels. I've been more at the national level, and Omar maybe slightly, especially this presentation is more at the international level. So I can speak to my experiences. So I think the first thing to mention is that it's not a case, so my experience, and I think that of my colleagues, it's not a case of designing. So I guess the impact agenda is very helpful to think about how we go about devising research that's useful for policy. And one of the key things that, especially since I've moved back to the UK from the US, that has really resonated with me is the idea of getting policymakers on board from the beginning, right? So the idea that actually, we just started this project that I mentioned with the Turing Institute, and so we actually have spent, this week and Monday, we were in Manchester meeting with policymakers, and we haven't even got the data yet. And it's because we want to get them on board from the beginning and actually say, this is what we're planning to do. Is this going to be of interest to you? What are the key policy, especially the timing, what are the key policy decisions that are coming up in the next couple of years that this could be informative for? So actually understanding the landscape is, I think, the most important thing when it comes to research and policy, is that actually policymakers have agendas, and the agenda is somewhat known, so it's very important for you to go and speak to policymakers really early and find out what is the agenda for the next few years, because if you come with something that actually was already decided last year, no matter how interesting it is, it's unlikely to make an impact on that agenda. So, and also it takes quite a long time to build relationships, right? So, for example, in Ireland, as I mentioned, it took a very long time for me to build up to a relatively high-level relationship where now I actually speak to the assistant secretary, right? But at the beginning, I was more a sort of, outside consultant. And so that is a long process that takes time. So in the case of the Turing project, we actually brought on board somebody into the project team who has a lot of experience working with UK policymakers and a lot of connections already. And so she's been kind of facilitating that. So I think it is that process. It's definitely not a case of doing a piece of research and then trying to kind of farm it around to different potential policy partners. I think that's rarely successful. You have to really get on board early and develop a relationship over quite a number of years. And I have to say I haven't really been yet involved at the sort of political level. I'm sure that's something that will come in the next few years. But as I said, I think that's more a function of how long it takes to kind of, to kind of embed yourself in that process. So as I said, in the Irish case, we're kind of beginning to kind of peek into that level of decision making. But I think it's something I probably might be better able to answer in a couple of years, actually.
So in my case, it has been quite interesting because the UNDP, as an international organization, is very keen in involving the stakeholders in the process of funding any of these projects. And for the project of Mexico, we're actually doing it at the federal level, but also at the level of 2 states. Because in Mexico, by law, not only the federal government has to publish a development plan when it takes office, but also every state, whenever there's a new governor, with very specific goals. And for example, Neave was mentioning that sometimes the policymakers already have an agenda set like a year ago or so. So our problem is our project is interesting because you can actually manage both things. So in this case, they already have the agenda. We entered when the new government took office, so they already had the goals. So now it's a question about how do we get there. But then the idea that the UNDP wants to develop is that we use this tool to actually, when a government is just taking office and is figuring out what is going to be the agenda, perhaps it knows already 2 or 3 topics, but not hundreds of them, then they can use the tool to identify where there is more potential in order to have a realistic agenda. And what has been very, very interesting in this activity is that we have run workshops with these stakeholders, with representatives of the different offices. And they have been part, for example, in activities like in our framework, you can differentiate between indicators that actually have policy instruments that the government can directly intervene, and indicators that you cannot really directly intervene, but they move because of the network of spillovers. GDP is an example. No government would tell you that they have an instrument to really affect GDP directly. It's an aggregate indicator of many other things. And in that activity, the stakeholders can tell us a lot. Oh, in my experience, I know that there is a policy instrument for this particular indicator. In my state, there is for this. In my other state, there isn't for this. So they really get engaged with this project. They really feel part of it, and it has been quite interesting to develop it together.
Okay, I think we need to close now. It's a big thank you to Neave and Omar for such great insights into the world of policy. And